All right, example number 5. This is another one that we need to look at. So here again, like a broken record, we look at our strategy. The first is, will the degree of this one, if we expand it, be greater than the degree of the one on top? Yes. So that checks the map. We can already begin from this point. And then also we can say that we look at the factors. So can we reduce this factor? No, it's okay. So this will have a single constant on as a numerator. And then here, if we look at this, x squared minus x plus 1, this is irreducible, because if I looked at the factor here, if I multiplied, the product will be 1. Okay, the product of these two will be 1, but then I cannot add 1 and 1, then I get a negative. Already we can see that this is irreducible, right? So we then look at the type of partial fraction that this will reduce to. So we look at the factors, the factors here, it'll be x minus 2, okay, or the roots. Then here, this is irreducible, so we cannot put a constant, just a constant on top, because there'll be a discrepancy between the, if for example, I say b over this factor, okay, you'll see the discrepancy. The degree of this one is 0, then the degree of this one is 2. There can only be a difference of 1. So here, this is 0, and then this is 1. 1 minus 0, that's 1. So if I have a square here, it means that I need x here. But then I cannot end here. I need a constant. We always have a constant here. So we need to have a constant on top. So that will be our constant here. Right? So this now, we are able to go forward and resolve. But remember, we said that we only mess around with this section here, okay, to make it similar to this, because this is already in its state. So let's continue here. We're going to say that our common denominator, okay, is going to be these two, so that it's exactly the same as that one. The intention is we should be able to cancel this out, or it should allow us to compare the numerator, the new numerator that we create here. So this one will give us a, because it takes care of this part. Then we have x squared minus x plus 1. Right. Then we're going to say here, we're going to have bx plus c. Okay. This comes in here and then gives us x minus 2. Like that. So carefully, that's how we expand. So this, we can actually already expand, or we can say that we can leave it like this and then just be able to pick the terms that we're going to have. But let's do it differently, because we haven't been expanding. So let's expand, so we see a different method. So this I'll expand. Here I'll say ax. Then here I'll say plus a. Then I'm going to expand this one. This will be bx squared. Then this will be minus 2bx. Then this one will be plus cx. Then this one will be minus 2c. Right. So I'm going to collect now the like terms, because here I've already cancelled these because they're similar. I can have them here, but we'll waste a lot of space. Okay. So I'm going to collect the like terms, which is ax squared now, because we've done the expansion. Then plus b x squared, right? Then we're going to go to the next degree, which is ax. Okay. Then here I'll have minus 2bx. Okay. Then plus cx, because this is positive, so everything remains as is. Then we have constants, which is a minus 2c. Right. So we have this. If I factorize, I'm going to get a plus b. Then, so this now we can equate to the first part, which is 4x squared minus 4x minus 2. So I can say a plus b, because these give me a coefficient of x squared. They're going to be equal to this. So I can say it's equal to 4, right? Then I can go to this next section. I can factorize negative and x. So meaning that I'll have a plus 2b. So a plus 2b equal to a plus 2b, okay, then plus c equal to 4. because this would have been negative. Okay. And then also, because we're trying to do a lot of things in the mind here, we make a few mistakes. Okay, this needs to be negative because we factorized a negative. This becomes positive. That becomes positive. This becomes negative here. And then this is comparing a negative and a negative section, so it will be positive here. Okay, then we look at the last part, which is a minus 2c. A minus 2c equal to this portion here, which is negative 2. Okay, so we have our linear equations here, and so we can solve these. These are it's the same. These are 3 variables, so we solve for the 3 variables. So we'll have a equal to a number, b equal to a number, and c equal to a number. All right. Okay, so this gives us our values. You can see a plus, like 2 plus 2 is 4, 2 plus 4 minus 2 is 6 minus 2, which is 4. A minus 2c, a is 2, minus 4 is minus 2. So these are, we can prove that those are correct. And then now what we do is we go and replace these in this one to create our partial fraction. So what will a partial fraction be? We can say that it's going to be a, which is 2 over, okay, 2 over x minus 2, right? Then we can say plus, here we're going to say it's 2x because b is 2, then plus c, which is 2, over, we maintain our bottom part here, our denominator. So this is our solved or resolved partial fraction. Okay, all right, all the best.